Hello, good day to everyone. I am Christine Ann S. Okoy, and I will be the first reporter of this chapter, which is the chapter 3. And I am tasked to discuss the scales of measurement, the nominal and ordinal. In statistics, variables or numbers are defined and classified using various measuring scales. And each level of measurement scale has specific characteristics that influence the diverse application of statistical analysis. In this chapter, we will learn about the four different types of scales, which is the nominal, ordinal, interval, and ratio scales. Let us define first what is the measurement. So measurement, it is the act of assigning numbers or symbols to characteristics of things, either people, events, whatever, according to rules. The rules used in assigning numbers are guidelines for representing the magnitude of the object being measured. So this means that the measurement refers to the meaningful assignment of numbers, and comprehending measurement scales is critical for interpreting the numbers allocated to persons, things, and events. For example, the assigned number 12 to all lengths that are exactly the same length as a 12-inch ruler. So next, scales. It is a set of numbers or other symbols whose properties model empirical properties of the objects to which the number are assigned. So scales of measurement are methods for defining and categorizing variables and numbers. Each scale of measurement has unique qualities that influence its suitability for use in specific statistical studies. So a scale used to measure a continuous variable might be referred to as a continuous scale, whereas a scale used to measure a discrete variable might be referred to as discrete scale. So let us now proceed to the continuous scale. So if we say continuous scale, it measures data that are numerical values that may be measured in theoretically infinitely small units. And an example of this is blood pressure, the height of children, the amount of rain in inches that falls in a storm, and the speed of cars. And if we say a discrete scale, it comprises numeric data that can only be whole numbers and has a finite number of potential values. So the number of students in a class correctly answered test questions. Those are the examples of discrete data. Measurement always involves errors. In the language of assessment, errors refers to the collective influence of all of the factors on a test score or measurement beyond those specifically measured by the test or measurement. So an example of this is the score of someone received on a test in American history. We might conceive of a part of the score as reflecting the test taker's knowledge of American history and part of the score as reflecting error. So the error part of the test score may be due to many different factors. So one source of error might have been a distracting thunderstorms going on outside at the time the test was administered. And another source of error was the particular selection of test items the instructor chose to use for the test. So next. So before I will discuss the first scale of measurement, I'll have a trivia first about the four scales of measurement. So the French word for block is spelled as Noir, and it is pronounced as noir. And that word is a useful acronym for remembering the four levels of scales of measurement. Each letter in noir is the first letter of the succeedingly more rigorous levels, which N stands for nominal, O for ordinal, I for interval, and R for ratio scales. So the first scale of measurement is the nominal scale. It is the simplest form of measurement. These scales involve classification or categorization based on one or more distinguishing characteristics, where all things measured must be placed into mutually exclusive and exhaustive categories. Since it deals with numerical properties, a nominal scale does not rely on numbers. Tags or labels are used to correlate value with rank. It distinguishes objects depending on the categories to which they belong. So an example of this are gender, marital status, college major, and blood types. Those are the examples of nominal scales. So these variables can only have two values, and individual test items may also employ nominal scaling. It includes yes or no responses. For example, considering the following test items. Are you actively contemplating suicide? Are you currently under professional care for a psychiatric disorder? Or have you ever been convicted on a felony? So, in each case, a yes or no response results in the placement into one of a set of mutually exclusive groups, which is suicidal or not, under care for psychiatric disorder or not, and felon or not. So, let us now proceed to the second scale of measurement, which is the ordinal scale. So, like nominal scales, ordinal scales permit classification. However, in addition to classification, rank ordering on some characteristics is also permissible with ordinal scales. So, the ordinal scale is a statistical data type in which variables are ordered or ranked, but there is no degree of difference between groups. So, the ordinal scale incorporates qualitative data. The term ordinal means order. It ranks variables and only allows you to quantify their value as higher or lower on a scale. So, an example of this is in business and organizational settings, job applicants may be ranked ordered according to their desirability for a position. Another is in clinical settings. People on a waiting list for psychotherapy may be ranked ordered according to their need for treatment. And in these examples, individuals are compared with others and assigned a rank, perhaps one to the best applicant or the most needy wait-listed client, and two to the next, and so forth. I think that's all for my report. My colleague will continue the interval and the ratio scale. So, thank you for listening and have a good day.